All right, hello everyone. Today's teaching assistant is Small Fry, who is not at all happy about being put on the table. Small Fry, show us your beautiful face. She is a 3-year-old rabbit, and I've also got her sister, Chicken. And I'm fostering her other two sisters, Frosty and Pierogi. Whoops, good beat. All right, you can go back on the tent. Bye. Rabbits make great pets, but they shed a lot. All right. I know last week was a lot, or I guess week before last week. So let's start with a wee little review. We learned about various types of validity and reliability and how to test for them. With reliability, we learned about internal consistency, so making sure that the scale, all of the items in the scale relate to each other, or that two different raters will use the scale in the same way, apply it the same way to the same phenomena. We also learned about some ways to measure validity. The weak ones are face validity and content validity, and the stronger ones are criterion-related validity and construct validity. There's the 5 different kinds within both those categories, and the important thing to know is just that they're much stronger and that they're all mathematically obtained as opposed to the weak forms of validity. So what we tend to do is with the concurrent validities, sorry, yes, there we go here, the ones right here, like predictive concurrent known groups validity, we're looking for some kind of regression model, and we'll learn about regressions in a few weeks. With the construct validity, we're looking more for correlations, so it's a little bit weaker than the criterion-related validity. That's what basically differentiates the two types, the type of math used to prove that the instrument is valid or not. We also learned about mediators and moderators, in fact, that a variable can be both a mediator and a moderator. A moderating variable influences the strength or direction of the relationship between the independent variable and the dependent variable. An example of that would be the relationship between stress and depression. We know stress has an impact on depression symptomatology, but we also know that those with higher levels of social support are better able to handle stress and have fewer depressive symptoms than those with low levels of social support. So in that case, social support is a moderator. A mediating variable explains part or all of the relationship between the independent variable and the dependent variable. An example would be that your grades might impact your level of happiness. However, that's likely mediated by self-esteem. If you have high self-esteem, even if you have low grades, you're still going to be happy. The grades are not going to impact you that much. So in that case, having self-esteem explains away part of that relationship between grades and happiness. We also learned about different ways that variables can be measured. So the 4 levels of measurement are nominal, where you've just got categories of things, ordinal, where those categories have an order, but there's no fixed unit of measurement. Then we've got interval, where they're continuous, and now you do have a fixed unit of measurement, as well as proportionate intervals between levels, and ratio, which is everything that includes an interval, except also there's that true zero that actually means the absence of something. What we're going to cover this week is descriptive statistics. So the purpose of descriptive statistics is to organize and summarize the data. What you have in raw data is just a whole bunch of information that's very difficult to understand unless it's summarized in some way. And that's what descriptive statistics does for us. These are the types of descriptive statistics that we're going to cover today, except for relative standing, which will be covered next time. So the simplest way to summarize our raw data is just to make a frequency distribution table. So in a table, we basically write how many times something happens for each participant in our data set. For instance, the number of therapy sessions attended, the number of clients you have, etc. We can also provide the information as a percentage. So that's the number per 100, or as a proportion where it's a part of 1. So a proportion is out of 1, a percentage is out of 100. And that gives us the frequency distribution table when we do it for each variable. Let's see what that looks like. So here we have a frequency distribution table for some information. A given score on a test. All right. So, oh no, number of pets. My apologies. It's the number of pets that people in this class or a class have. So the number of pets is our variable of interest, and right here in this first column is the potential answers. So 0, 1, 2 pets, 3 pets, 4 pets, etc. And then the second column, labeled by the F, that's the frequency count. So this is what's known as the absolute frequency, or exactly how many people provided this response. So 10 people have 0 pets, 13 people have just 1 pet, and 12 people have 2, etc. Next, we've got the percentages. So because there are, 50 people in our group, this 10 is equal to 20%. So 20% of our sample has 0 pets, etc. The relative frequency now allows you to compare groups, basically. So this is that proportion. So out of 1, we've got 0.2 that have 0 pets, 0.26 that have 1, etc. And you see here that the numbers are the same, just that the decimal point is in a different place between the percentage and the relative frequency. The cumulative frequency also allows you to make quick assessments of the data, namely where most of your sample lies. So what it does is it takes the people with 0 pets and adds them to the people in the next group. So the number of people with 1 pet. So 10 plus 13 gives us this number, 23. So 23 people in our sample have 1 pet or less. And then with 2 pets, it's 35 people have 2 pets or less, 45 have 3 pets or less, etc. The cumulative relative frequency, the last column, gives us our cumulative frequency as a proportion. So now we know here, looking at this 0.7, that 70% of our sample has 2 pets or less. So the vast majority of our sample has less than 2 pets, and a very small minority has more than that. All right. You can also graphically represent this continuous data. So this is what's known as a histogram. You'll notice that the bars are touching here. This is what differentiates a histogram from a bar chart. So the frequency of our event occurring is on the x-axis, and the y-axis, the horizontal axis, has the number of pets. So as I said, 0 pets are owned by 10 people within our sample. We can also do a frequency distribution for qualitative data, but in that case, the only thing that we can provide are the frequencies, the absolute frequencies, the percentages, and the relative frequencies. We can't estimate cumulative frequency or cumulative relative frequency, etc., because it just doesn't make sense, right? Because we can mix up the order for nominal and ordinal data, and it doesn't make sense to add up the numbers because they're not in a predetermined order. So here with this example, we've got employment status, and we know that 680 people within our sample are employed, or 68% of the sample. And that's repeated for each of our categories. It wouldn't make sense to add up employed and unemployed because, again, we can just change up the order and it would make any kind of cumulative frequency completely useless. So for qualitative data, the only thing we have is that absolute frequency and a percentage, or in some cases a proportion. But what you're most likely going to see is this percentage here. To graphically represent categorical data, you use something like a pie chart or a bar chart. So not a histogram, a bar chart which has that space between the bars. All right. So we just covered plotting frequencies. Now let's look at measures of central tendency. So measures of central tendency are a way of very quickly explaining where the majority of the data is. So it's a data reduction strategy that tells us where the center of the distribution is located. And we use 3 different measures: mode, median, and mean, which when you report, again, depends on the scale of measurement of the variable. Simplest one is mode. This one is possible to do with ordinal, interval, or ratio data. The mode is really just the most frequently occurring score. So with our pet example, for instance, most people had 1 pet, so our mode is 1. Within this example here, our mode is 5 because that occurs 3 times within our distribution. This can be either unimodal, bimodal, or multimodal. So if you have more than 1 mode, that's what's known as a bimodal distribution. And multimodal is where you have 3 or more modes. The median is the next one that we'll cover, and that's literally the middle point. To get the median, you need to order your numbers in order. So let's say that this is, again, number of pets within our little sample. Now, 1 person has 1 pet, 2 people have 3, so we write each 3 individually. 1 has 6, 7, 8, 9, etc. And the middle number is the one that we take as the median. It's otherwise known as the 50th percentile, or literally the point at which half the cases are above it and half the cases are below it. If when you arrange the scores from lowest to highest, there's an odd number of scores, the median is going to be the one right in the middle. But if there's an even number of scores, so you have 2 that are in the middle, you just have to take the average of them. So 4 plus 5 is 9, divided by 2 is 4.5. You can use this when you have an ordinal scale and when the distribution is skewed, and I'll show you what that looks like. The average, or mean, is the one that I'm hoping you're most familiar with from high school. We do things like calculate our class averages, etc. And that's the exact mathematical center of the distribution. So it's adding up all the data points together and dividing it by the number of data points. We can only use the mean with interval and ratio data. We cannot use it for nominal or ordinal data. One problem with the average or mean is that it's not an accurate representation of your data when the distribution is skewed because it ends up being pulled by extreme values. Let me show you what I mean by that. Because with the average, each data point is given equal weight, when you have any outliers that are extreme, they have a big impact. Here is the average Canadian income back in 2020, where we see that it is at 51,300. However, when we look at the median, so the halfway point of those scores, we see that it is actually much lower, 39,500. The reason for that is all the way over here in the chart, that are not quite pictured, are all those millionaires and billionaires, and they're pulling the average towards themselves and inflating it basically. So it seems like Canadians are a lot richer than they really are if you only consider the mean. That's why when we have a distribution like this with a very long tail, we say that it's a very skewed distribution, and we report the median as opposed to the mean because it's more accurate, it's more representative of what is actually going on within the data. Another way of summarizing the data is to use measures of dispersion. So these ones describe the spread or variability of the data. They're reported in conjunction with the mean and indicate how close or how far the data are from their mean. So that's why I love this here. You can see this cat is quite spread out versus this cat, which is very, very long and skinny. The simplest way of explaining that variation is just to provide the range, and that's the difference between the largest and the smallest value. You can either explain the range as 6 minus 3, or a range of 3, or you can just have left it at this. So our range is from 3 to 6. Either way is valid and accurate. Again, range and all of our other measures of dispersion can only be used with ratio and interval data. You can sometimes use it with ordinal data as well, but in that case, you have to report the actual responses, not the numerical values that represent those responses. Next up is the interquartile range. So we want to use this when we have a very skewed distribution because it's a lot less sensitive to outliers. And basically, this is just the range of the middle 50% of participants. So we're cutting out the top 25 and the bottom 25% of participants, just so that we know, here's where the majority of our sample is distributed. A disadvantage to this method, of course, is that when you cut out 50% of your sample, it could be that that's the 50% of the sample that's related to your research question and important information is lost. So in general, this is less frequently used than some of the other measures I'm showing you today. The next thing that we use is the variance, and this is the deviation from the mean. Now, I know the information presented here is a lot, but basically, the only reason we need to add up the deviations from the mean is so that we can calculate the standard deviation, and that's the one that's actually important. The standard deviation is the average distance between a value and the mean. So the larger the standard deviation, the more the scores differ from the mean. The smaller the standard deviation, the more tightly clustered around the mean they are. This is the one that you're going to see reported in articles, and that you're going to have to report yourself every time you report an average for our weekly assignments and for your final assignment.